Load cells have lots of applications in industrial processes that are very valuable, and strain sensors and load cells are essentially the same thing. Strain sensors can be used in lots of structural applications to measure compression, tension, and bending forces. And when you attach them to a wireless sensor, they can have wide ranges of applications. In addition to that, a type of strain sensor is a load cell. And load cells are often used in scales to measure weight and also forces of both pushing this way and this way, or measuring weights. One of the things we're really proud of in the whole LEAP sensor product line, but especially in the complex sensors of strain and load cells, is the ability for this system to work right out of the box. No configuration in the field, it's ready to go. And let me literally demonstrate that. Here is a LEAP system that just arrived. We'll open it up and fire it up. The first thing is our gateway, and I'm going to plug that in first because it takes about 2 minutes for it to come up and run. Then we also have our LEAP sensor, LEAP strain sensor, for load cells and strain sensing. And we'll fire that up as soon as the gateway gets going. In the box, we also have the power supply for the gateway, which I'm going to plug in. And then this particular LEAP system uses a USB interface. Although LEAP systems can also run with cellular connections and Ethernet connections. So it's a very flexible system. Typically when we're doing early proof of concept testing, clients like to start with USB connected to a personal computer so they can try the sensor and make sure it's going to work in their application before they buy more. So I've plugged it into the wall and I've plugged it into my laptop computer, and we'll give it about 2 minutes to come up. One of the things that makes strain sensing and load cell sensing so difficult is that the load cell or the strain sensor has to be balanced and calibrated, and that's typically in the field. In the case of a strain sensor, after the strain sensor is installed on the structural member, it usually isn't balanced, meaning that it will look like there's strain on it when actually there isn't. And that initial process of balancing the strain sensor can be very time consuming, even for an expert. And so one of the really unique and powerful features of the LEAP strain and load cell sensor is its ability to be very quickly and easily balanced or zeroed and calibrated in the field by somebody that has no experience with strain or load cells. Okay, now our gateway is up and running. And one of the really great things about the LEAP system is it is all IP web-based, meaning there's no software to install on your computer. The user interface for this system actually resides in the gateway. The user interface is accessible through any web browser, and we're going to demonstrate that right now. So in your user manual that comes with the system, there's a few simple instructions on how to get started. There's also a sheet that gives you your login and password. After watching this video and seeing how easy it is, you probably will never open this other than looking for your password. So I'm going to go and now I'm going to enter the URL, and there is the login, and I'm going to use my my admin password. And I'm going to enter my password this time. And the system's logging in now. It's connecting to the software in the gateway. And once that's up and going, we'll connect the sensors and we'll be up and running. Okay, there we have the screen, and there's my 2 strain sensors. I'm simply now going to turn them on, and it will take a few seconds for them to connect, and my system's up and running. There we go. There's our first reading. One of my strain sensors at the top here doesn't have a load cell connected to it, so it's going to read out of scale or real high value. This is the sensor that we'll be doing the tests with and the demonstrations. They're set up right now to transmit every 15 seconds, and that's a pretty fast rate, but you can change that very easily through the user interface. Now, one of the things I really want to demonstrate is in the field, doing your zero balance after the strain sensor or after the load cell is installed is one of the more difficult things, even for an expert. It can take specialized equipment, precision resistors, great soldering skills, and we've used the edge computing capabilities of the LEAP sensor to make that easy. So I'm going to demonstrate that right now. I'm going to pick this sensor. I'm going to go to the configure screen, configure device, and when it comes up, I'm going to go down to the auto calibrate, auto zero function, and it will let me auto calibrate this sensor. Okay, takes a little bit of time the first time, but it'll be much faster the second. I'm going to scroll down here. Right there is where I can set my transmit and sense how often I sense and transmit. And down here, right there, one simple button to click for auto balance. I'm going to click that button. I'm going to click save. I'm going to confirm it. And now, when I go back to my device's screen, you're going to see this configuration pending right there for the sensor. Now, it's going to take 2 transmissions for it to communicate to the sensor. The first one, it's going to pass the new values, and the second one is where it's going to take a reading. Now, let me point out that this sensor is actually calibrated for a span of 3,000 pounds. So it's pretty darn close to zero, not exactly, but for a span of 3,000 pounds, that's a really good, really close to zero. And just to do a little quick demonstration, I've got a weight here that I'm going to put on the load cell and get it to change its reading. There we go. Should say somewhere around 5 to 6 pounds, I believe, on this bottom sensor. We'll let it transmit one more time. It's transmitting every 15 seconds. And there we go, 7.2 pounds. Now, if that wasn't exactly right after we installed the load cell or the strain sensor in the field, one of the things we talked about also is the ability to quickly field calibrate. So we'll do the same process. We'll go to configure the device. This time it comes up much faster. We'll go down to the bottom screen, and by changing the scaling slope after the sensor is zeroed, we can calibrate the sensor. One of the other really nice things about the LEAP strain and load cell sensor is its ability to measure both compression and tension, or loads pushing or pulling. And again, going to our screen here, that can be adjusted with the scaling offset and the trim voltage. And the user manual that comes with it provides a really easy explanation on how to do that. And again, you'll have a calibrated, zeroed, balanced load cell or strain sensor up and running within minutes of your package arriving. Okay, I'm going to cancel out of the configuration screen, go back to my main screen. I've taken the load off of my sensor. It's back to about 0 pounds, and I'm ready to go. There are other videos on our website on the LEAP sensor product line explaining all of its powerful features. Click on the top under LEAP sensors, and we also have a wide range of off-the-shelf, ready-to-go LEAP sensors under our products page. Thanks for taking the time to watch and learn more about the LEAP load cell and strain sensor.